again. Here is lesson 2 under curve sketching, and we are looking at minimum points and maximum points. The question before us is find the turning points on the curve s cubed plus 6s squared plus 9 and distinguish between them. Now, like I mentioned in the previous video, that for you to be able to obtain, when they say distinguish them, which one is the maximum, which one is the minimum point, that's what they're asking. So we have to first of all obtain the turning point, like, or the stationary point. Those are the vocabulary you can hear regarding this. So solution, turning points. That is what we want to show. Want to represent that. Here our dy over dx is, look at this function. Our dy over dx, this will become 3s squared if we differentiate s cubed. If we differentiate this one, 6s squared will become 12x, and if we differentiate 9, we will have 0. And from these statements, this will be equal to 0. And then we are solving for this. We solve 3s squared plus 12x equals to 0. What is common here? You can factor out 3 and 3x. So we factor out 3x, we'll be left with x plus 4. That will be equal to 0. So from that, we could say that our 3x equals to 0, or x plus 4 equals to 0. From here, you can tell that your x will be equal to 0, or your x will be equal to -4. So these are the values of x we can obtain and that correspond to the turning point. So when x equal is 0, then what will be our y value? This is our y value. That's just the function we are given, s cubed plus 6s squared plus 9. That's our y value. Now when x is equal to 0, our y will be 0. If you plug in 0, you plug in 0 here, that will be 9. Okay, and then when x is -4, you have your y to be -4 cube plus what? Plus 6 -2 square. -4 square plus 9. -4, the cube of -4 will be -64. And then the cube of 4, the square of 4 is 16. 16 times 6, that is 96, plus 96, and then plus 9. Now what is -64? -64 plus 96 plus 9, that will give us 41. So turning points are, now when x was 0, y was 9. So we have 0, 9. And what? When x was -4, y was 41. So we have -4, 41. Now here comes the next question. Which one of them is a minimum point and which one of them is a maximum point? And that is why we now need to test. We need to test. Now to test it, let me erase this part so that we can test. So test for minimum and maximum points. Okay, first of all, like I mentioned, you take the second derivative. The second derivative of, remember when we take the first derivative, our dy over dx was, if you look at this, that would be 3 over dy over dx was 3x squared plus what? 12x, isn't it? So over here, what are we going to get? Second derivative of that will be 6x plus 12. That's our second derivative. Okay, so if we have gotten the second derivative, the next thing is that we want to check for the values we have gotten before. When x equals to 0, okay, our d square y over dx square, second derivative will be 6 plus 12, and this will be equals to 12, and 12 is greater than 0. Therefore, we can tell if this value of x gave us a figure greater than 0 from the first condition, we know it is a what? It is a minimum point. Then this particular point right here, 0,9 is the minimum turning point. And you can tell that the other one will be the what? The other one will be the maximum point, but we have to also test for that as well. Now, when x equals to -4, then our d square y over dx square will be equals to what? Will be equals to 6 -4 plus 12, and that will be -24 plus 12, which is what? Which is equals to -12, right? And that is less than 0. So we can say, therefore, the second point we had, that is -4,41, is the maximum turning point. And that is it. That's the solution to the question that was written. Thank you.